Sometimes great discoveries happen not because a scientist spent years working on formulas, but simply because someone forgot to wash the dishes. That is exactly how humanity got its first antibiotic, penicillin. At the beginning of the 20th century, medicine had already achieved serious progress. Doctors had learned to perform surgeries, used anesthesia, and knew the basics of anatomy and microbiology. But at the same time, humanity faced a huge and seemingly insurmountable problem: bacterial infections. People could literally die from the smallest things. It might seem like just a scratch from a nail or a small cut while shaving, and soon blood poisoning would develop, from which it was almost impossible to save a person. Pneumonia, angina, or meningitis often became a death sentence. Means that could specifically kill bacteria simply did not exist. Yes, antiseptics were known, for example, iodine or carbolic acid. Doctors used them to treat wounds, and they really did destroy microbes. But the problem was that these substances killed not only bacteria, but also the patient's living tissue. It turned out the treatment could cause no less harm than the disease itself. It was like trying to drive cockroaches out of a house by setting the whole house on fire. Therefore, at the beginning of the 20th century, any bacterial infection remained deadly, and doctors were practically powerless. The medical world desperately lacked a real weapon against pathogenic microbes. Alexander Fleming was born in Scotland and in the 1920s worked in London in the laboratory of St. Mary's Hospital. He was a bacteriologist, a specialist who studied microbes, their behavior, and ways to fight them. Fleming was not a typical bookish scientist. His colleagues recalled that he was often deep in thought, and his workplace looked like real chaos. The table was cluttered with Petri dishes, test tubes, flasks, and notes. The laboratory was in disorder, and this became the subject of his colleagues' jokes. But despite his outward negligence, Fleming had an extraordinary gift of observation. He could notice details that others simply ignored. In science, this quality is sometimes more important than pedantry. After all, history knows many cases when chance became the beginning of a great discovery. So it was with Fleming. His untidiness, which many considered a flaw, eventually played a key role in saving millions of lives. In 1928, the very event occurred that forever changed medicine. In the autumn, Fleming left on his work table several Petri dishes where he was cultivating colonies of Staphylococcus, a dangerous bacterium that causes purulent infections. The scientist went on vacation, and the dishes remained in the laboratory. When he returned and began to sort through his experiments, the scientist's gaze stopped on one unusual dish. On the surface of the nutrient medium, mold had unexpectedly appeared. But even more amazing was that around the colony of this mold, the bacteria had disappeared. Around it, a clear zone had formed, as if someone had pushed the microbes away. Fleming became interested. The mold was clearly producing some substance that killed bacteria or prevented them from growing. For a bacteriologist, this was incredible. After all, what doctors all over the world had dreamed of had accidentally grown right in his dish. The scientist began to study the fungus. He determined that it was a representative of the species Penicillium notatum. It was from the name of this fungus that the word penicillin later came. Fleming began conducting experiments. He tried to isolate the substance secreted by the mold and tested it on different types of bacteria. The results were astounding. Penicillin killed the pathogens of many of the most dangerous diseases: pneumonia, meningitis, angina, blood poisoning. Fleming realized that he had stumbled upon something truly revolutionary. If this substance could be obtained in pure form, medicine would gain a powerful weapon against infections. But here the difficulties began. Isolating penicillin turned out to be very difficult. It broke down quickly, and the scientists could not obtain it in large quantities. All his experiments remained at the laboratory level, and it was impossible to make a medicine for patients out of it. Fleming did not give up. He published an article about his results, spoke about the finding at conferences, but the scientific community greeted the discovery coldly. Many believed that penicillin had no practical application and treated Fleming's work as a curious but useless experiment. More than 10 years passed. Only in the late 1930s did interest in penicillin revive. At Oxford University, a group of scientists led by Howard Florey and Ernst Chain decided to check whether Fleming's discovery could be brought to a practical result. They worked in difficult conditions. They literally had to collect penicillin drop by drop from huge volumes of cultivated mold. But the effort paid off. They managed to obtain relatively pure substance and begin testing it. The results were astonishing. Penicillin really treated bacterial infections that had previously been considered fatal. When the Second World War began, the antibiotic became salvation. At the front, thousands of soldiers were dying not from wounds, but from infections. But thanks to penicillin, mortality dropped sharply. It literally became a miracle drug that changed the course of medicine and the fate of millions of people. The appearance of penicillin marked the beginning of a new era, the era of antibiotics. For the first time in history, humanity had obtained a weapon capable of specifically destroying bacteria without destroying the human body. For this discovery, in 1945, Alexander Fleming, Howard Florey, and Ernst Chain received the Nobel Prize in Medicine. Their work became a symbol of how science can change human destiny. And all this happened because one day, a scientist left a dirty Petri dish on his table.
Today, antibiotics are a familiar thing for us. If a person has pneumonia or tonsillitis, the doctor prescribes pills and the illness retreats. It is even hard for us to imagine that just 100 years ago, everything was different. The history of penicillin shows great discoveries are often born by chance, sometimes from disorder on a desk, sometimes from attentiveness to small details. Mold, which most people would have simply thrown away, gave humanity millions of saved lives. Penicillin became not only the first antibiotic, but also a symbol of the fact that, in science, even the smallest accident can change the whole world.